All right, so maybe we could then start. Once again, hi everyone. Thanks for joining us today. I see some familiar names and also some new people. My name is Shiva Garamani. I'm the CEO of Asigmo, which is a company based in Vienna. And we, generally speaking, deal with data science training on different forms. This is our second webinar. Some of you also joined our webinar back in November on AI ethics. And today, Manuel is our guest and our also future trainer who is going to be the main speaker of these showstoppers in operationalization of data science and ML. I'm also recording the meeting, so if you have security concerns, please feel free to keep your videos turned off. And actually, without further ado, I'll pass it on to you, Manuel.
Okay, great. Thanks, Shira. So, yeah, maybe we can start with a short introduction round. I will probably introduce first myself and the topic. As you already read, I will show you today what are the usual showstoppers when talking about operationalization of data science or machine learning projects. And what I would be actually interested in, yeah, you can see the agenda. I will go quickly through it later on. But what would be quite interesting for me, also to know how much detail level I can focus on during the presentation is if there is anybody who already tried or actually already is operating successfully machine learning models in production. Feel free to speak up, raise your hand, and quickly introduce yourself and give me a short example, maybe what you're currently doing and how you actually, or what you are using in production. Yeah, what I forgot at the beginning, I'm Manuel, currently at the Walter Group, leading the data ops team, and we are focusing there on making the life of data science teams easier, but not just data science. We are actually turning the whole company into a data-driven enterprise. And yeah, I can show you some tips and tricks today, what we did and how we failed actually in the past. So is there anybody who wants to give a short introduction until we wait for the room, because I see it's still filling up with additional listeners. So we have another 2 to 3 minutes. So if you feel comfortable, please raise your hand and introduce yourself and maybe give me an example about what you're using in production. Let's check. We have to open the Teams room. Okay. I mean, otherwise, we could also proceed. I see it's already 12:05, so probably most of the people already joined who actually planned to attend the meeting. Therefore, let's simply continue. Okay. Okay, let me come to the agenda. So what we'll show you today in this free webinar is I'll give you a short introduction into ML Operationalization, what it actually is about, the usual challenges, also some examples out of real-world scenarios and usual roadblocks. Then we will talk about how to overcome those obstacles. And at the end, of course, we'll have a Q&A session where you can ask questions. Feel also free to just write them in the chat, and Shiva will just let me know about the questions, and I will try to answer them. If you feel you have to ask something in between of the presentation, feel free just to write down your question in the chat room, and we will come back to it either in between of the slide deck or at the end. Okay, yeah, introduction. Let's start with it. So on a high level perspective, on a high level view, if you think about what a data scientist actually wants to do, he wants to get data, write intelligent machine learning code, or some algorithms in Python, or train a model, run a model, and then he wants to actually repeat it and constantly improve. The problem is, and that's not something that I just wrote down. It's paper that Google officially published a few years ago. What a data scientist today actually ends up doing. If you see in the middle, the black, the small black part is actually the machine learning code, and the rest is actually a really huge fraction of everything else that he has to think about: configuration, data collection, data verification, analysis tools, serving infrastructure, how to serve a machine learning model. Of course, there are enough how-tos and tutorials in the internet, even YouTube videos, but often if you're part of a huge enterprise organization, it can get tricky. And I will explain you later on during the presentation what I mean by that. Funny part is, this was released in 2015, December, by Google. So we are already now 5 years away from that, even more, and still not much. There's still not much change in the market, actually, and also huge enterprise organizations are quite struggling with the topic. And yeah, by the way, I recommend to everybody to go through that paper, and maybe also to send it to the IT guys in your company, maybe some IT architects or IT managers. It's really a good read. It's a good starting point. And the sad thing is, actually, this is still not enough to successfully operate machine learning in production. So all those things that you saw that are necessary apart from the machine learning code, that's not everything. And I want to highlight some of the biggest challenges in the operationalization of machine learning. Of course, you start thinking about, how do I actually get from research to a release candidate? You usually start with some Jupyter notebooks, or you start with R, and then you actually need something that you can operate in production and integrate with other systems. How do you actually deal with production incidents or bugs? That most of the time people start thinking about incidents and bugs once a product is released in production and the first incidents are starting popping up, and then everybody is actually running away and doesn't want to fix the whole stuff. Also important, who is going to approve new versions before going live? Who is the one saying, okay, there's a new version of my machine learning code, of my new component, I want to release it now, and who is actually approving that? Are there any gatekeepers? Is it happening automatically? We'll talk about that later. And one of the most important questions: who should be part of a data science project, of a team that is delivering some data science deliverable? Last but not least, you have to spread trust in the data science deliverables. So people have to really trust your deliveries. They really have to be able to understand what you're doing to a certain amount, at least. So if you remember the picture at the beginning, where the data scientist really wants to focus on his machine learning code, on training the model, releasing new versions, comparing it, etc. So how to get now from research to a rock solid release candidate? Of course, that's again a high level perspective, but it will help me later during the presentation to explain the different roadblocks. So if you look at the first row, the usual data science tasks: upload a data set into a data store, clean and prepare the data set, spawn maybe a Jupyter notebook. Usually you do it in the cloud, then you can quickly spawn a new Jupyter notebook instance, or you do it locally on your laptop. Then you explore the data, you develop the model. At the end, you export the model and you think, okay, now I'm ready to kick off, I can maybe hand it over or throw it to somebody of the IT guys, and they take care about deployment. But the real life scenario is that actually on the other side, there's something that nowadays people understand as data engineering, or it's not just the data engineer that is required. Actually, you're talking about a whole data ops, about a whole data ops culture, because data ops is not a team. Data ops is a way of operating, delivering software components. And on that side, you usually have some kind of automated CI/CD pipeline. CI/CD, some of you probably already heard it. It's continuous integration, continuous delivery, where you have some kind of distributed training, model testing, model optimization. Then you have maybe model and metadata storage. And at the end, of course, also somebody has to take care about model serving, and also handling the request response of that model. Really being able to scale that model in a production environment to handle huge loads. So at the end, it really is again the question if you're getting the right person for the right job. So what the little Robin in the middle is showing you, those are definitely tasks that a data scientist should not bother too much about. He should actually get somebody who can help him with this, or even do it for him. When we talk about a dedicated CI/CD automation for ML pipelines, I mean really the whole end-to-end process, from building, packaging, testing, deployment, comparing versions or results, so comparing different models one with each other, and at the end, of course, also releasing. So there are definitely you need some data engineers, some sysadmins, some sysops guy who can support you with that, who already did that before. Of course, when talking about serving, model serving, but also monitoring, quite important not to forget that. Especially when monitoring, try to implement continuous measurement, throughput and SLA, so service level agreements. You have to have some thresholds to be able to react on some events, on some all of a sudden huge load happening on the systems. You have to see, okay, what's happening, what's going on now, and we'll talk about this in the next slides. So how you can actually get ready for really tackling all those challenges. So yeah, if you see in the last slide, you probably, some of you might think, okay, now it could be quite easy. Let's simply ask the IT guys for help, and they will actually start helping me to implement the whole stuff. But most of the time, the real life scenario is not really a good one, because the usual roadblockers we'll talk about now is on your way to production, you will have several discussions and get many questions from various people. It may be different in a startup organization, in a small little team where we're just talking about a handful of people, 2, 3, 4, 5 people, maybe up to 10, everybody working in the same room. You all work towards the same goal. Okay, that's easy. But if you're working in a large enterprise organization, all of a sudden, when you're ready with your data science work, you have to talk to IT architects, to the IT operations team. Maybe you need additional servers, maybe you need additional resources, infrastructure. The testing team, usually those are the ones approving and measuring quality. So they are approving if new versions can get released to upper stages like pre-prod production. And last but not least, you have also to convince management that your deliverable is ready and can be put actually into a productive environment without breaking anything else. So at the end, also probably some of them will ask if you can explain the results of a machine learning model. That can also be a tough task if you didn't thought about how to actually answer that question, especially if you train a model based on historical data and it's not really completely explainable. So switching slides, a little bit slow, sorry for that. yeah. So that was too quick. So let's overcome the obstacles, and I will show you how you can really start with it. So I'm really sorry, my connection seems to be quite bad. I have to change that. Just a second. Yeah, it's the right slide now. So, in fact, as you probably already thought of, or actually even saw on your own, or realized in real life scenarios, 80% are organizational challenges and showstoppers because of the lack of empathy. To be honest, most of the time it's not the technology, it's not the used programming frameworks, languages that are the roadblockers. Most of the times it's really communication issues, lack of empathy, of course, of both sides, not just IT department and facing a new data science team coming in and that wants to release some new software products. But yeah, I will show you how to at least try to get that problem to a really small amount. So let's overcome the obstacles. How do you actually start? You have to adhere to rules and talk to so many people to really try to have actually a good outcome out of all those discussions. So you have to talk to some architects. Maybe there are separate cloud architects if you're operating something in the cloud using a Google Cloud platform or Microsoft. There are data engineers, infrastructure engineers, business analysts you have to convince probably. And I think this is one of the most important slides if you're in an enterprise and think about how can we structure our data science team, or how can we actually enable our data science team to really deliver machine learning into production. There is a book called Team Topologies, and they talk about this enabling team, and that's definitely the one to start with. So start with an enabling team, and then sure you get data enthusiasts into the team right from the start. Include at least one experienced software engineer because he can help you to ensure that you deliver rock solid and production ready deliverables, microservices, whatever. And with the time extended by additional data engineers and platform engineers, operations guys, as per need, that might be quite specific from use case to use case, from company to company, depending on how many products you are working on, how big your data science team actually is, etc. But the concrete idea of this enabling team is that they are really going into the other teams, into the other software development teams, and into the software architects teams, talking with them and actually making room for a new way of thinking, for a new way of delivering software products. Because all of a sudden, they're not just experienced they're not just experienced programmers writing software and wanting actually to release that software into production. We're now really talking about the democratization of software engineering. So there are a lot of other guys, for example, data scientists, who are able to implement software with Python, for example, and or train the machine learning model, and they actually want to release that. So nowadays, software architects, they should be prepared for that question, for that scenario. They actually should somehow create an environment that really can make use out of those deliverables. And I think the worst scenario is if somebody tells you, just give us your code snippets and we will re-engineer the whole thing, refactor it completely, and then we can release it once it adheres to our guidelines and IT governance. That's really not helpful, because at the end, you want to be able as a data scientist to evolve your model, to really constantly improve, to change it, to release new versions on a weekly, monthly basis, whatsoever. So now you probably also question yourself, are there hybrids? Are there people who can actually be data scientists, but at the same time also understand how to deliver rock solid software? I mean, really 50-50 skill distribution. I'm data scientist and I really know how to deliver distributed systems. Usually it looks different in reality. Usually you have 80% data science skill and something like 20% of the data engineering skills, where you learn a little bit of programming, a little bit of platform engineering. Of course, it's just one example. It can also be the other way around. You can be data engineer or programmer and with a high interest into data science, and then you actually get some skill level into data science, but in fact you're a software developer. Of course, it's easier for you to really understand how to deliver rock solid data science projects, but at the end you can't be 50-50. So expectation most of the time is quite different from reality. So are there hybrids? To a certain amount, of course, but you should not expect that one guy can handle everything. And what we now with this Asigmo webinar want to change is we want to provide you with a magic suitcase to begin with. You should be able to, over time, of course, pack your own suitcase with techniques, tools, learnings out of our webinar, out of our trainings that we plan to do in the future, to get to a certain amount where really IT departments and other people start really trusting your deliverables as a data scientist. And I will show you what to focus on first. Maybe you can think about, again, the 80-20 principle. So Pareto is also in our presentation here included, but let's ensure that a data scientist can handle at least 20% or somewhere between 10 and 20% of the specifics that a so-called microservice nowadays usually needs to adhere to. When talking about microservices, probably a lot of you already heard that buzzword. Today it's really probably even not a buzzword anymore, but a microservice is probably in every company, in every organization, you have a slightly different definition of what microservice means for that IT department, for that particular IT department. But at the end, it comes down to the same principles. So let's begin with some deeper details. Once the slide switched for me, finally. Yeah. What should be in that suitcase? We'll focus on the most important and relevant parts to achieve a better acceptance. Rule number 1, use Python, not R. I really have to say this because I saw a lot of data scientists in the past 3.5 years asking me if I can actually deploy their data science deliverable. They are now ready, they are finished, if I can put it to production. And what they give me is some R code snippet. We somehow have to try to operate in prod, even integrated with other systems. Please believe me, I tried it for almost half a year, almost a year even, 2.5 years ago. We gave it a try. We really tried to operate a quite simple simple product that was developed in R with the R server. It was really impossible to operate such a thing in production. It's really difficult to scale. It's really difficult. It's really difficult to integrate it with other systems, with monitoring systems, with logging systems, etc. And you could, of course, use it for some POC phase or explorative research phase. Still, R is quite good for that, of course. But really, rule number 1: if you want to be part of a software engineering factory, of a software team that is really delivering some kind of value for their end users, start using Python if you aren't already using it. Also important for REST APIs, use existing libraries or frameworks. For example, Fast API is really a quite good and popular one. It delivers you out of the box Swagger definition, so an open API definition, quite self-explaining, and their website is really good with good tutorials. I saw a lot of teams trying to reinvent the wheels, trying to implement REST APIs on their own, trying to host and create the whole Swagger definition on their own. Try to figure out what the community is using and pick a product that actually suits you best. You have to implement meaningful log outputs, and at the end, most of the companies nowadays are using the Elk stack with Kibana and Elasticsearch, or other logging, another logging framework, actually, landscape. For this part, implementing meaningful log outputs, you can do it, of course, without the integration and the connection to the Elk stack or Kibana. But maybe it's a good idea, once you start thinking about logging, to talk to some of the IT guys or the IT architects and ask them, okay, how can I plot out or print out proper log outputs, and what's the best way to incorporate it with our existing logging landscape, if it's Elk stack, Kibana, whatsoever. Most of the time, there should be somebody who can help you. And one of the most important things, we'll come to this also more in detail right now, is monitoring of your component. It should be up and running from the start. So you should really, when you release even the first prototype of your model or Python deliverable, you should have some kind of monitoring in place where you can get a quick overview about the current status. We'll talk about that in a second. And last but not least, if applicable, deliver a container, for example, Docker. It's easier. The people, especially the IT guys, nowadays like containers, and they can quickly handle it, quickly think about possible operationalization scenarios, etc. So when talking about monitoring and measurement, you should really start with it right from the beginning, and I want to give you a quick example. It's something from our production environment where we have a Python algorithm in place that is actually calculating the ETA, so the expected time of arrival of a truck. And we really monitor a lot of stuff like requests by specific version. So for a given version, how much requests do you get per 5 minutes? What's the throughput? There are actually two different methods deployed. What's the latency for all those methods? Model capacity utilization. So it's quite important that you also know, okay, and here on that slide with model utilization, I mean, how much more throughput could we actually handle if it continues with the load like that? You really need that. At the end, you have to be able to quickly analyze the root cause analysis. If some incidents happen or all of a sudden some other events are happening, you get high load on your system, on your component. And at the end, of course, you as the developer, as a data scientist, will get questions from folks like, okay, can you please have a look? Your stuff is not working. Please tell me what we should do. Should we simply restart? What can we do about it? By measure everything, I really mean everything. If you look at the second picture, you now see, in our case, it was integrated in a Kafka landscape. So we also measure the topic latency trends, the topic latency by partition, actually, because in Kafka you have several partitions per topic. And it's really important that you start measuring everything. Okay, those two arrows are actually now for this picture. We also have to be patient when stating inside your monitoring system when stating what's okay and what's not okay, because there's always a technical okay response, especially for a software developer. HTTP 200 usually means it's okay, nothing breaks, there's no error. But there's also a separate interpretation of the model response. So the model can respond with not okay or error, but in fact it's a known, it works as designed. In that case, what we tried, you see now the trend over the past 6 hours, and what we try is to automatically correct our geofences. So we have geofence triggers for our loads that we are delivering to our customers. And once the truck arrives into that geofence, we get a GPS signal. And at the end, what we try is to automatically correct a given geofence. So we start usually with the concrete address and a circle with a radius of, I don't know, maybe 200 meters around that GPS coordinate. That's the starting point. But over the time, as the trucks start arriving on that delivery station, it doesn't have to be the circle anymore. It can change. The whole geofence can change, and that's what this actually data science component is doing. And here you see, of course, all those responses were okay, but in fact, only 52 of them were cases where a given geofence that already existed was corrected by the data science solution. And yeah, by the way, the technology stack that I'm using for those monitoring and measuring screens that you just saw is Grafana with Telegraph in the back. But this would be too much details now. We will have a concrete training that Shiva will probably also tell you more about at the end, where we really tackle all those details about how to implement those things and how to implement them actually right from the start as a data scientist. So that you don't have to, because those are simple. This is really simple stuff. If you use the correct tools, the correct frameworks, you can get that quite quickly up and running. With a little help of the IT guys, this will work for you. So you'll probably ask yourself about, do I really need to start always with monitoring systems and proper logging outputs, etc.? What about keep it simple? What about keep it simple principle? Of course, over the time, you could talk about some kind of evolution of the level of your product. Usually you start with a POC, proof of concept, you use some mock data. It's normally not integrated with any other system. And of course, it can be a single Jupyter notebook deployed on your local desktop machine, your laptop, where you just implement a proof of concept to get some grip, to be sure that your idea is a good one. Maybe the next evolution is some kind of prototype. The prototype could start based on the POC, but already try to integrate with other systems on a development or testing stage. So usually you have the picture of some data source or some triggering system triggering your Python code, and at the end, you're producing some output and doing something with it, or handing it over to another system. And the fun part, the really tough part we're talking about is, and that's really the part from prototype to MVP, to minimum viable product. This is meant to be the first release candidate. That's the part when you have to think about implementing proper logging, incorporating my component with a given log framework or logging system in our company, having a rock solid and good monitoring. You have to be able to handle incidents in production quite quickly and figure out what's the root cause for it. And that's definitely the toughest part. So from prototype to MVP. So once you reach that state, you should already start thinking about, what's the correct way? How can I best do that? So In the MVP, you usually have a data, again, some triggering system, a data source you fetch your data from. And what you now see is a wrapper, and inside the wrapper is the Python code. Usually what we see nowadays is the wrapper can be a container, it can be another programming language, Java, Golang, Rust, that is taking care about all those events, all those requests that are going to your new data science product, handling the request, catching them, and then handing it over to the Python script. So, sorry, is there a question? Okay. Yeah. So what I just mentioned before, we're thinking about a machine learning operationalization training to help you really pack your magic suitcase and get you ready for takeoff, so that you are able in the future to really develop rock solid data science products, actually deliverables that can be deployed right away on a development stage, on a testing stage, and with some tweaks and additional help of the IT guys, you will be able to really operate the whole stuff in production. And yeah, as the time already flies by, I would actually jump to the last slide. Question and feedback is welcome. So feel free to answer any questions you have. I will take a look to the chat now as well. So check.
Thanks, Manuel. There was actually a question before. Somebody asked about the name of the paper that you mentioned in the beginning.
Yes, it's Managing Technical Debt in Machine Learning Systems. Let me check. I can send the link to the chat.
Yes, that would be great. Also, I would like to anyone who has questions to simply unmute themselves and post any questions that you have now that we have more time.
Technical debt in machine learning systems.
Hey, Manuel, thanks for the intro. I think it was really good. One question that I have is actually, you showed that you're using Grafana for monitoring, but is there also a way, like, does Grafana and like all the Kafka topics that you set up, do they also monitor like the inputs and the predictions that the models are performing, or is there another way of creating this feedback loop around like the input data and the predictions that you're receiving back?
So at the end, we are using Grafana because it was the tool at hand in our IT department, and it was quite easy convincing the architects and the other IT folks. Hey, I have integrated it with Telegraph to our Prometheus server, and you can show all kinds of monitoring and measurements in Grafana. They were quite happy with that, and it was the easiest and quickest way for us, frankly speaking, to really start kicking off. And of course, we started implementing all those kinds of measurements that you just talked about with Grafana. Frankly speaking, I think there are even better tools to achieve all that. If you probably think about various cloud products nowadays, usually you have at least in the Google Cloud, from what I know, and also I think Microsoft, but I'm not sure how it's called there, has a solution for all that questions. So you're definitely right. It's quite important to measure also for you as a data scientist all those KPIs to see, okay, what's the performance of the whole model, how much actually success rate do we have, etc. We do that right now still with Grafana at Walter Group, but there are definitely better, there's better tooling existing nowadays.
Yeah, because this is actually something that we see, that like once you have developed the models, that at some point you also want to integrate all the feedback, that you kind of, I don't know, integrate it into the model to train it back again. Cool.
Yeah, that's the feedback loop is quite important. So especially model retraining based on the feedback loop is something that is a hot topic. It was already last year, but especially this year, a lot of companies are trying to implement that. And also we, on our side at the Walter Group, are working towards the model retraining. What we currently do, what you usually do is you actually have to collect those measurements, and based on that collection over certain amount of time, for example, daily or weekly. If it's daily, at the end of the day or during night, you try to do a model retraining and quickly produce a new model version. And at the end, of course, you have to start measuring that new model version to see how much difference is there in the results actually when comparing to the previous version before you release it to production, because that's also quite important. So if you, let's take the scenario, you train weekly, at the end of the week you train a new model, and then for a certain amount of time, for a few hours, you're operating both models in production, running some kind of A/B testing to see, okay, compared to the currently activated version in production, what are the results of the newer versions? And to give you an example, if we are talking about a model that is predicting prices, so many companies are trying to predict prices on almost anything. But when talking about Walter Group, it could be the use case that we want to predict the price for a load from A to B. So the price prediction will be produced by the machine, and at the end of the week, based on new data and based on the feedback loop, you train a new model version. Simply because if you don't do that, you don't go with the market. So if you implement a pricing model based on historical data and you let this pricing model over half a year in production, it's already too old. I hope everybody knows what I'm talking about. But if you train it weekly, you have the chance to really go with the market to really realize when prices are going up or down. And at the end, even if you have a newly trained model version, you have to ensure to run that model for a small amount of time, for example, for half a day, maybe a day, run it in parallel in production to the existing version and start comparing results to see if the newer model version is actually predicting higher prices or lower prices. Of course, it depends. In that case, what's A to B? Are we driving from Vienna to Munich, or are we driving from Austria to Russia, or even from UK, especially yet after the Brexit? So those are all stuff where you need. Well, all those blocks, if you remember the picture regarding hidden technical debt in machine learning systems, those blocks are getting more and more if you're talking about comparing newer model versions with older versions, really trying to maybe automatically verify, okay, is the can I just release the new version because from the source code itself, nothing changed. Just the data that is used to train the new model changed. So at the end, you can get to some automated way of releasing newer versions to production based on your model retrainings and comparison with the previous models, etc. And maybe you start asking yourself, how do I do A/B testing properly, for proper A/B tests, you should also consider asking the IT guys for help. Of course, you need people that are interested into the topic and interested into helping you, but at the end, there are various scenarios. You can do some canary release. So you can start releasing the newer model version just to a small amount of use cases or to a small amount of users within your organization. So start with, I don't know, 5 to 10 users, see how it fits. If the prices are good for them, roll it out to 100 users. If those users are now happy with the newer prices, you can go further. Or you just do it in parallel all the time and constantly measure in the back, of course, how the newer model would operate if it would be the active one predicting the prices. But that's definitely not easy. So it's if you don't have all that set up, you as a data scientist can't do that on your own. You really have to have what I just told also in the presentation, some kind of enabling team, a mix of software engineers and some data engineers and maybe some sysadmins who are really enabling you to do all that stuff. I hope that answers the question.
All right. Thanks, Manuel. Everybody else also, as I mentioned before, feel free to just unmute yourself and ask any questions that you might have. In the meanwhile, I would also like to ask you to maybe spend some few seconds on the link that I'm just posting into the chat area, as we are actually designing a training program on ML Ops, and your feedback would be really appreciated, and it would help us design the program in a way which reflects the needs of the community better. We will, of course, keep you also posted on the dates of the training. If you would like to stay informed, you can just provide your email address or take a look at the website of Asigmo and subscribe to our newsletter, as we will also be sending out information about the course over there. So, all right. Well, thank you, Manuel, one more time for spending this time. It was amazing.